Good morning, dear students. Welcome to this session on pre-stressed concrete. So, till the last session, we have talked about Unit 2 of your syllabus, which is majorly the analysis of pre-stress. Finding, in the other way, if you say, finding the resultant stresses in the pre-stressed concrete member from different concepts. Okay, uh, we have used the superposing the stresses from both pre-stress and the service loads. I mean, both dead load and live load, and we have used the pressure line concept, and also we have used load balancing concept. Likewise, from different aspects, we have calculated the pre-stressed concrete stresses in resultant stresses in PSC members. Okay, and then we have talked about the stresses in tendons, where the profile of the tendon is going to change the stress that you induced in the tendon. Finally, we have talked about the moment required to develop the cracks in PSC members. Okay, so this is overall last about 28 sessions that we have talked about Unit 2. Okay, now let us talk about Unit 3 of your syllabus, which is the whole Unit 3 content is to talk about loss of pre-stress, which means you are going to induce some pre-stress value through the tendon to the concrete. Okay, so what exactly that you have to concentrate on is what is the effective value of stress available finally in the concrete. That is what is important. Okay, it is not that the value that you have tensioned the tendon, say 1,000 megapascal stress is induced in tendon, let us say, but that is not important for us. What is important is what is the value of stress that is being induced in concrete. That is what is required. Pre-stressed concrete. Okay, what we want majorly is we want some prior stress in concrete which can take care of the stresses coming from the loads. This is what is a primary need for us. Okay, so uh, the value that you are the value of stress that you are inducing in steel, and further it is transferring that stress to the concrete. So in this process of the final value available in concrete, whatever you have induced 1,000 megapascal, for example, is not going to be the same 1,000 in concrete. Okay, so we will have some loss in pre-stress. So that is what is now to be discussed. Okay, so as I mentioned here, you can see the IS code, the corresponding clause that is to be followed exclusively for loss of pre-stress is 19.5.2. Okay, so this is about the IS code that is to be followed and the clause, respective clause that is to be followed. Okay, so now if you see the syllabus content is like we have to now calculate the loss of pre-stress both in pretension and post-tension members, and we will categorize what are the losses in pretension members, what are the losses that occur in post-tension members, that we will see. The first thing to study is What is the value of loss of pre-stress due to elastic shortening of concrete? That is first content. Then due to shrinkage of concrete, there will be some loss of pre-stress. How much is that? How to calculate? Then due to creep of concrete, how much is the loss? And due to relaxation of steel, how much is the loss of pre-stress that happens? Okay. So, and slip in anchorage, what will be the loss of pre-stress? And differential shrinkage, something is mentioned in your syllabus, but it is not applicable. It is already covered in this shrinkage of concrete. Okay. So 3.6 we will not be having in the foregoing discussions, right? Next, frictional losses. What will be the value of frictional loss? Okay, and total losses allowed for design in the concrete, right? So this is what is your the syllabus content that is to be studied. Okay. So let us just visit this IS code, whatever is there, just to have an idea where you have to actually really, if you open your IS code, where do you see all those losses? Okay, so just open your IS code along with me. So just open the IS code IS 1343-2012 and go to 19.5.2. So class 19 you have to open. So 19, okay. So what 19 says is class 19 is on general design requirements. This is class 19, and what is 19.5 is pre-stressing requirements is the 19.5 class, and what we are in is this one 19.5.2 losses in pre-stress. So these losses in pre-stress are again subdivided into category wise. There are 6 subcategories. So 19.5.2.1 talks about loss of pre-stress due to creep of concrete. Okay. So this is like page number 24 in your IS code that is to be seen. So this just go through these content, how to calculate loss of pre-stress due to creep of concrete. And subclass again in 19.5.2.2, it will talk about loss of pre-stress due to shrinkage of concrete, and that is again pointing to class 6 to 4. So go to class 6 to 4 for calculating loss of pre-stress due to shrinkage of concrete. So let us go to 6 to 4, class 6 to 4. Okay, right. So this is about class 6 to 4. Right. So it is to talk about shrinkage. So how to calculate the shrinkage strain? This we have discussed in properties of concrete, high strength concrete in unit 1 of your syllabus. Okay. So unit 1 we have talked about how to calculate all these shrinkage strain, where you have two subcategories in that total shrinkage strain, consisting of one is drying shrinkage, another one is autogenous shrinkage strain. Okay, so this is about the shrinkage calculation. You have to follow 6 to 4, where the 19.5.2.2 says you follow 6 to 4 for shrinkage calculation. This is all about shrinkage calculations. Okay, so autogenous shrinkage values are given in a tabular form. Just if you just go back to your unit 1 discussion, that will show you how to calculate the shrinkage strain. Okay, so that will provide you the sufficient information for the uh, you know, calculating shrinkage losses. Okay. And similarly, creep also we have 6 to 5, which is to be followed the IS code. To calculate creep coefficient value. So depending on creep coefficient, we will be finding losses in the pre-stress. So that is also available in 6 to 5. Okay. So this is regarding the losses in pre-stress due to shrinkage and creep, where they are pointing to, you can see even 19.5.21 creep. You have just theoretical content here, which means you have to follow the creep strain calculation from 6 to 5. Then to calculate shrinkage, you have to follow 6 to 4. Okay. Right. That's about those two phenomena, where creep phenomena and shrinkage phenomena, uh, uh, the inducing losses in concrete. Now, loss of pre-stress due to relaxation of steel, which is 19.5.2.3. So you have a table to follow. So we will follow the table 6 for all these calculations. Okay. So this is about calculating loss of pre-stress due to relaxation of steel. Okay. So you have to take straight away the value in terms of percentage. Okay, so you have some initial pre-stress available in the steel. So whatever is percentage given here for a particular initial stress value, straight away you take that much percentage and as a loss of stress. So if you have say 1,000 megapascal is induced as pre-stress, so 3% is the loss of pre-stress if the initial stress is zero point 0.6 times its characteristic strength of steel. Okay, got it. So that's how when the initial stress is higher, in higher the value, higher is the loss. Okay. So if you induce only half of its characteristic strength, then there won't be any relaxation loss, zero. Relaxation loss is zero. So only if it is zero point 0.6 times of its characteristic strength. So imagine the characteristic strength of steel is 1,000, and you have induced a stress of 500 megapascal, which means 50% of the characteristic strength. So relaxation loss is zero. Okay. And if you induce 600 megapascal, out of 600, 3% is lost, means 18 megapascal is lost. Okay. So likewise, and if you induce 700 megapascal, you if you tension the steel to read 700 megapascal, the loss is 5%. Okay. 35 megapascal is lost. Okay. So likewise, I mean 700 into 5%, 5 by 100. Okay. So that's how you straight away calculate with a simple tabular value. Okay. The relaxation loss. That is about relaxation loss to calculate. Next, coming to the loss of pre-stress due to elastic shortening of concrete, you have to follow 19.524, and loss of pre-stress due to slip in anchorage, you have to follow 19.525, and loss of pre-stress due to friction, you have to follow 5 to 6. Okay, so there are 6 category given in the IS code. Whatever we have mentioned in our syllabus. Okay, you have elastic shortening, shrinkage, creep, relaxation, slip, and friction. The 6 types of loss of pre-stress are there. So these 6 category are available in this IS code. as subclasses in 19.5.2. So each subclass, say, I mean, creep of concrete is 19.521, shrinkage is 19.52.2. Likewise, you go on, read all those classes, just follow IS code, IS 1343 2012. Okay, so that is about the syllabus content to study in this unit 3. Okay, right. Let us now talk about what are the losses that occur in pretension members and what will be the losses in post-tension members. Or else, what are the loss of pre-stress which occur immediately, and what are the losses of pre-stress that occur over a period of time. Okay, so there are two such no, uh, categories. You can divide the losses, loss of pre-stress into category based on two criteria. One is depending on the type of member, whether it is pre-stressed or, I mean, pre-tensioned or post-tension, uh, depending on the type of member, and depending on the time, depending on the time. I mean, whether it is immediate or whether it is after certain period of time. Okay, so that is about the categorization of losses. Okay, so just to follow this no, uh, loss of pre-stress, uh, uh, when we started talking about pre-stressed concrete, the pre-stressed concrete application, the most important variable is the pre-stressing force. This is the one that is uh, the reason for pre-stress to induce in concrete. In early days, it was observed that the pre-stressing force doesn't stay constant, and it reduces with time. As we have talked about, early attempts of pre-stress were not successful because the value that you can induce is only very very less value, and over a period of time it was found that the pre-stress is gone and there is no pre-stress available in the member, and it was just behaving like a normal RCC member. Okay, so that's how uh, uh, the losses have come into picture. Okay, even during the pre-stressing of tendons, and the transfer of pre-stress to the concrete members, there is a drop of pre-stressing force from recorded value in the jock gauge. Okay, so that is also being observed. Okay, so various reductions of pre-stressing force are known as losses of pre-stress. Okay, so the values that no, that you feel, that you see the pre-stressing force is reduced, those we call it as losses. Right, now to classification of losses in terms of, as I said, time. Okay, so which will be categorized as immediate and time dependent. Okay, so those two categories we'll talk about. And immediate losses occur during pre-stressing of tendons and the transfer of pre-stress to the concrete member. This is the immediate loss when it happens, immediate losses when it happens. They are during pre-stressing of the tendon, during jacking, and from tendon to concrete during the transfer of pre-stress, the immediate losses will occur. And time dependent losses will be occurring in the service of the member. When you made ready the member and transport it to the construction site, then erect it to its position and use it in the structure. So during its service, there will be losses. Those we call them as time dependent losses. So losses are categorized into two. One is immediate and another one is time dependent. Immediate losses are elastic shortening of concrete, friction loss, anchorage slip. These three out of six, you have six losses. Out of six losses, three are immediate and three are time dependent. Creep is a time dependent, shrinkage is time dependent, relaxation of steel is time dependent. Creep of concrete, time dependent. Shrinkage of concrete, time dependent. Relaxation of steel, time dependent. Okay. So these three are being time dependent classes. These three are being immediate losses. Elastic shortening of concrete, immediate loss. Friction loss, immediate. Anchorage slip, immediate. Okay. So there are three out of six, three are immediate losses and three are being time dependent losses. So next comes the types of losses depending on the type of member, whether it is pre-tensioned or post-tension. Okay. So if you see pre-tensioning members means uh, first we jock the tendon, we pull the tendon, then we pour the concrete will get hardened, then we cut the wires. Okay, then the transfer of pre-stress happens. This is what is pre-tensioned member. Okay. uh, the tensioning happens prior to hardening of concrete. Post tension means the tendon is stressed after concrete gets hardened. Okay, that is the difference. So pre-tensioning member, which are the losses occur in pre-tensioning members. So elastic shortening of concrete loss will be there in pre-tensioning. Relaxation of steel, stress in steel will be there in pre-tensioning member. Shrinkage of concrete will be there in pre-tensioning member, and creep will be there in pre-tension. What are all absent then? There are two things absent. One is friction, another one is anchorage slip. So these two are absent in pre-tensioning member. Remaining four are present. So pre-tensioning members, there won't be any friction because the tendon will never move with respect to the concrete. Both concrete and tendon are firmly bonded. Okay, so because you are already now pulled the tendon and then you have poured the concrete got hardened. So there won't be any no differential movement between concrete and steel. Hence, you don't find any frictional losses in pre-tensioning members. Similarly, anchorage slip will not be there at all because you don't use anchor at all. Once the member is pre-tension, we will be cutting the tendon, and the tendon will be there in the concrete, and you don't need any anchor to hold the tendon. Okay, the bond between concrete and steel itself is the anchorage purpose. What happens in pre-tension members, right? And when it comes to post-tensioning members, okay, losses due to elastic shortening of concrete, losses due to elastic shortening of concrete will not be there, if all the wires are simultaneously tensioned. Say if you have a duct provided in the post tension member, we have a duct, and say for example you are having five tendons in that duct. So all five tendons, if you place it in the jock and pull it at a time simultaneously, then there won't be any elastic deformation in the concrete. Okay, no losses in the pre-stress. But okay, if you first pull one tendon, anchor it, then go for jogging operation of the second tendon, then we expect the elastic deformation of concrete. So if the wires are successively tensioned, means one after the other, then there will be loss of pre-stress due to elastic deformation. Okay, so this is like conditional, may present, may not present, depending on the condition. But remaining five are present definitely. Relaxation of steel will be there, loss due to shrinkage of concrete will be there, and loss due to creep of concrete will be there. Loss due to friction will be there because the tendon will be moved inside the duct. So there will be frictional losses, and there will be anchorage slip because once you pull the tendon, we will use different anchorage devices which we talked about, like Fresinet, Gifford, plenty of them. Okay, so we will be using all those anchorage devices to grip the tendons, so the slip will occur, so that will induce the losses. So post tensioning, all six present, and one will be no conditional. First loss of stress, like elastic deformation of concrete, may be present, may not be present, depending on a condition. But pre-tensioning members, only four losses occur out of six. There won't be any frictional loss, there won't be any anchorage slip loss. Okay, right? So that's about the overall picture of this unit. What are all different losses you have? There are overall six types of losses are there. Then you categorize depending on the immediate and time dependent, and categorize depending on the type of member, pretension or post tension. Okay, so we will be talking about each one, how to calculate, and then we'll be solving the problems in this topic. Okay, so uh, uh, follow regularly to get the confidence in this unit, which will be uh, uh, very much depending on the IS code classes. Okay, right, thank you.